Okay, so if you look at this, you'll notice that there's an inequality. And the problem with inequalities would be that there's infinitely many solutions probably that make it true. And we've got to find them. And so we can't just be like, I found one that works. Awesome. Let's go with it. Well, the problem is we've got to find each little group, and there can be different intervals that make it true. In fact, this one has 2 different intervals that make it true. So I think it's like from -4 up to -1, and then also from 2 to infinity. You're like, how am I even going to find that? This is very tricky. And so there's a list of steps we're going to employ as we do this. Okay, step 1 is combine all the terms into one factored fraction on one side of the equation. Okay, that's less than 0 or greater than 0 or less than or equal 0 or greater than or equal 0. So get everything to one side and make a common fraction. Okay, that's the first thing. And then the second thing is we're going to create number lines, okay, with the key values on them, okay, after we factor it. So then we'll factor it, and we're going to create some number lines to be able to say, let's find those critical values and let's create test points within each of those regions, say which regions have answers that make it true, okay? And so we're going to find the regions that make it true, okay? So we're going to do test points and see that there's a couple ways to do this. If you Google this problem, be like, how are you doing this? I'm going to teach it pretty straightforwardly and say, hey, try the points within each region. Some of the regions will be yeses, some will be nos, and we're going to find the ones that are yeses. Okay, so get everything to one side and make it into a single fraction and factor it. Okay, so the first step is we're going to subtract the term on the right to the left. And so we have x over 2 minus 5 over x plus 1, and then minus x minus 4 over 3. Okay, it's going to be a good time. So we've got 3 fractions, and now it's greater than 0. So we got it to be greater than 0. So it's got to be either greater than 0 or less than 0 or greater than or equal 0 or less than or equal 0. So that's what we got to get to. And then the second step is let's get a common denominator. Okay, we're not going to cancel out the common denominator. We're going to get a common denominator. Okay, so step 1, get everything to one side. Step 2, get a common denominator and make a single fraction on the left side of your problem. Okay, so our common denominator, I spy a 2, a 3, and an x plus 1. We're going to need all those common factors, and we're going to use that as our common denominator. So I'm going to have to multiply this last fraction by a 2 and an x plus 1. I'm going to have to multiply the middle one by 6, and I'm going to multiply the first one by 3 and x plus 1. Okay, and so again, we're trying to get a common denominator so we can have a single fraction, and times this one by 6, and then times this one by 2 and x plus 1. Okay, get a common denominator, add up all the fractions so you have a single fraction, and we're going to factor it to see what are the critical values on our number line. Okay, so we want to find the regions of a number line that will work. Okay, so we got to find where are some critical values, and so we'll find those by factoring. So step 1, let's subtract. So on the first fraction, we get 3x, and it has to be multiplied by x plus 1. So we're going to get 3x squared plus 3x. And the second fraction, you're going to get minus 30. The third fraction, we're going to have to, wow, this is a lot. Let me think. We're going to do 2 times x minus 4 and x plus 1. And we're going to have to subtract it. So let's FOIL these out, and we get x squared, and then we're going to get plus 1x minus 4x minus 4, and then we're going to distribute a negative 2. I'm distributing a negative because there's this negative sign right here. And so you're going to get negative 2x squared. If I combine these, I get negative 3x. When I distribute the negative 2, I'm going to get a plus 6x. And then I'm going to get plus 8. It looks like an outstanding fraction. Let's combine like terms. It looks like an x squared. I see plus 9x. And then I see minus 22. And then it's over a 6 and an x plus 1. And that is greater than or equal to 0. Again, we've got to factor it to find the critical values. The numerator will factor. If it doesn't, we botched it. Okay, so we get I bet you it's 2 times 11. Yeah. So I'm going to rewrite this. So we've got x plus 11, x minus 2 over 6, and x plus 1. So our critical values are, if you look at every factor, okay? So when we graph things, you know the top factors and the bottom factors mean different things. But in this problem, every single value that makes it 0 is going to change the signs and cause it to be, we want to figure out which regions will make, which values for x will make this greater than 0. Okay, so critical values are x equals negative 11, x equals 2, and x equals negative 1. So there's just 3 critical values, and we're going to use each of those critical values. So on the number line, you got negative 11. And then we've got, let's see, negative 1. And then we got 2. Okay, I put them in order on the number line. Like, make sure you've got them, like, negative 11 is smaller than negative 1, but 2 is bigger than both of those. So make sure you've got a number line. And basically, normally it's like every other region will have an answer. Okay, I'm using open circles because our problem has a greater than sign. Okay, if it's greater than or less than, use an open circle. If it's solid over there in the problem, you're going to fill in each of those circles with the exception of the bottom. The bottom can never be 0. And so if at the point of negative 1, you would always keep this an open circle because the bottom can never be negative 1. Okay, that's not a point. And so, but because it's greater than or less than, all the circles are going to be open, just like the question. So what we've got to do is say, okay, we got to pick one form, okay? And the form that I would probably pick would be either this one here, okay, where it's just a single fraction, or this factored form. I would say, which will the value work? Okay, and you may, I find it helpful not to use factored. I'd like to use 6x minus 6. Again, you can work with plus 6. You can work with whichever one you want. And if I try x is equal to negative 12. Okay, try x is equal to like negative 2. These are test points. Say, do the points in this region work? I would try, say, 0, because 0 is a value in between those two. And I would try x is equal to 3. Okay, so again, I'm picking a point in that region between the critical values to say, do the answers in that region actually make the problem true or not? So I'm going to use this version right here and try negative 12, okay? And so if I try negative 12 into the original problem, and I would not go up here. I would probably pick the single fraction one. So if you do negative 12 squared plus 9 times negative 12 and subtract 22, and I'd put that in my calculator and put it over, you could do 6 times negative 12 and then plus 1 and see what answer is that. Is that answer greater than 0? Okay, and so I would try it and see if it's true or false. And the answer is no, it's not going to be true. And I can take out my calc and see what I actually get for the answer. So I'm going to do negative 12 parentheses squared. And I'm going to use the fraction. Okay, why? Because why not? Okay, you got a good calculator. So plus 9 parentheses negative 12 parentheses, subtract 22. And I'm going to put that over 6 times negative 12, and then plus 1. Okay, what I got was negative 14 over 71. Is that greater than 0? Negative 14 over 71? No, that's not greater than 0. So the answer is no. These are not solutions. If you tried another one there, none of them would work in that region. Okay, we're doing a test point. Say, do the points in that region actually work? Okay, so the next thing is, normally, I've only seen it about once where they don't vacillate between yes and no's on your number line. But if you try like negative 2, all right, how do you try negative 2? Well, you try it in one of your functions forms. I will probably use this one right here. Okay, and so say, okay, let's take negative 2 squared and then plus 9 times negative 2 and then subtract 22 and put it over 6 times negative 2 and then plus 6. So we can almost do that in our calc, but we don't in our brains, we don't need to. You can do -2 squared. I'm going to use the fraction because why not? And then plus 9 parentheses -2 minus 22 over -12 plus 6, and I got 6. So is 6 greater than 0? Yeah, it is. So that means these values are solutions to our problem, okay? Put a smiley face. Hey, we did a good job. Now, probably the next group is going to be a no, but you can try it. Try 0. Does it work? So if you plug in 0 to one of your forms, I'm going to do 0 squared plus 9 times 0. That's still 0. Subtract 22. Put it over 6 times 0, and then plus 6. And I got -22 over 6. Is that greater than 0? And the answer is no. Okay. So no, not so much. Those solutions won't work. And if you try any of the points in between those critical values, no, they will not work. Okay, the last thing I'm going to try is something in the last region. I bet you it'll work because it's normally every other. So try 3. So if you do 3 squared, okay, so 3 squared, kind of put some dumb parentheses there, but all right, who's watching? So we're going to do 3 squared, and it's not negative, so it's not going to really change something. Plus 9 times 3 minus 22, and put that over 6 times 3 plus 6. All right, we're going to get 9, and I'm going to use the fraction. And plus 27 minus 22 over 18 plus 6. And guess what? I got 7 twelfths. Is 7 twelfths greater than 0? And the answer is yes, it is. So these solutions will also work. So we're just doing a test point where we find the critical values. So we get everything to one side. We factored the left side. We took the critical values on top and bottom, and we plotted those critical values in order on a number line. And we tried test points in each region between those critical values, including towards infinity, to say, where are the answers that make this problem true? Because there's infinitely many values. And so the answers that make it true are from -11 up to -1, union with from 2 to infinity. Those are the answers that make this problem true. And anything you try between those values will all make it true. So let's try one more just for funsies. Okay. So this one says, I want this fraction to be greater than that fraction. Okay, step 1, get everything to one side because you want 0 on one side. Step 2, make it into a single fraction by adding or subtracting what you see. So you get x minus 2 over x plus 4. Subtract off x plus 1 over x plus 10. We need to get a common denominator so we can easily find the critical values, okay, by factoring. So let's multiply this factor by x plus 10, and the second fraction we're going to multiply by x plus 4. And notice this haunting subtraction sign. So once we FOIL out the numerator, we're going to have to distribute a negative to that. So we're going to get x squared. I'm doing this in my head. We're going to have plus 10x minus 2x. So that would be plus 8x minus 20. And then the second one, I'll FOIL it out, and then I'll distribute the negative. We've got x squared. 4x plus 1x is 5x. Did it in my head. And then plus 4. And we do need to distribute this together, so let's do it. So we get x squared plus 8x minus 20 minus x squared minus 5x minus 4. And so our numerator will be x. Let me switch this up because we got no more space. All right, let's see what we can do. X squared minus x squared is gone, so we're going to get 8x minus 5x is 3x. And then negative 20 and negative 4 is going to be negative 24. Over the denominator is x plus 10 and also x plus 4. The numerator will factor, and we need to do it. So we've got 3 and then x minus 8 over x plus 10 and x plus 6. And then it's going to be greater than 0. Okay, so this is going to be our critical values are x equals 8, x equals, that's a 10 there, I don't know, I wrote 16, x equals negative 10, and x equals negative 2. And so we make a number line, make sure you plot the values in order. We've got negative 10, and notice the original problem has greater than or less than, so everything's open. if it was closed, if it was or equal to, everything would be closed except for the values in the denominator, because your denominator can't be 0 ever. Okay, so those critical values would still be open. So we've got -10, and the next one on our number line is -2, and the biggest number on our critical value is 8. These are all open circles, and let's find the fraction we want to use. Probably, I don't like to do it in factored form, and so probably I would do 3x minus 24 over x squared. I'm foiling out these things. X squared plus 14x plus 40 has to be greater than 0. That's probably what I'm going to do, because I do prefer to evaluate things without parentheses. I don't know. You can do parentheses if you want. I don't. It's up to you. But I want to find a critical value in each region. So for the region that's between -infinity and -10, I would plug in, say, maybe -11. Maybe between, in this value, I would plug in x equals -5, maybe. X equals 0 fits well between -2 and 8. And then, say on this one, you could plug in x equals 9. Again, we're doing a test point to say, do the answers in this region work? And if one will work, they all will. If the one won't work, none of them will. Okay. Now, unless you did poor math, but we're assuming we're going to do competent math. We're using our calculator. So we're going to do 3 times -11, and we're going to subtract 24 and put it over -11 squared, and then plus 14 times 11, and then plus 40. And we're going to say, is that answer greater than 0? Okay, so we're going to plug it in and see what we get. I have a hunch that it's not going to work. So we're going to do 3, again, grab a fraction, parentheses, -11, and then minus 24. Try that over -11 squared, in parentheses, -11, outside the parentheses squared, plus 14 parentheses, -11, and then plus 40. Okay, I got -57/7. That's not greater than 0, okay? So it would be, no, that's not going to work, okay? None of those should work. Now, I bet you, again, it really is generally always every other. So let's try x equals -5. So you do 3 times -5 and subtract 24. Put that over -5 squared plus 14 times -5, and then plus 40, and see, is that greater than 0? So I'm going to try 3 parentheses -5, subtract 24, and then put that over -5 squared, and then plus 14 times -5, and then plus 40. And guess what I got? 7.8. Is 7.8 greater than 0? And that is yes. So that means -5 works, and probably everybody else will work too. If you want to try more points, you can knock yourself out. Next one, love it. I'm going to plug in 0. If 0 is in a region, grab it. Use it. It'll be pretty easy to try. So if you plug in 0, you get 3 times 0 is 0, minus 24. Put that over 0 squared, which is 0, plus 14 times 0, and then plus 40. You get -24 over 40. Is that greater than 0? Not on your life. No, it's not. Okay. The next group is try 9. I bet you it's going to work. Okay, so let's try 9. Let's try 3 times 9, and then minus 24. Put it over 9 squared plus 14 times 9, and then plus 40. See, is that greater than 0? Yes or no? Grab a fraction and jump right in. 27 minus 24. Hey, we almost don't need a calculator on this problem. Okay. And then we've got 81. And then plus 14 parentheses 9. And then plus 40. Guess what? You get a positive number. It is greater than 0. Bing, bing, bing. This is a yes. Fill it in. So our regions for solutions would be all the values from -10 up to -2 unioned with 8 to infinity. There you go. Those are the solution sets that make this true. So bring everything to one side, make a single fraction, factor the top and the bottom. Those are your critical values. Graph them in order from left to right. Okay, make sure they're placed on a number line. Like if you put 2 smaller than 8 on a number line, you're going to have an issue. You've got to make sure you line these up so that it's going to be like, first comes a -10, that's the smallest one. Then comes -2, and the next one comes 8. And then we're checking points in each of those regions, say, are they true or false? And it generally will be every other one. All right, well, thank you so much. Have a good day.